Okay, we're going to work on some examples here of determining a derivative by definition. So remember, we talked about this. M tangent is the limit as h goes to 0, f of a plus h over f of a divided by h. But what we're saying here is that was f prime at a. So we're going to use this. And I'm actually going to look at some questions from my worksheet here. So this is where we're at. We're going to look at some questions from the worksheet. I said I was going to give you guys some extra examples. So here they are. And we're going to call this here f prime at a. So number one is an interesting question because the constant, the function they give you is a constant. They're saying 4 here. So I want to point out we have a constant function. So if we're going to apply this definition at some arbitrary point, remember this is at some a value, right? So we're finding the derivative at a. So that's kind of what they're saying here. So we want to say, what is f prime? And this is at the location. You know, x is a or just at a. So to start to use this definition, I need to plug in an a. And since, you know, we have a constant, this means f of a is 4. The function is constantly 4, irregardless of the value of a. So I'm now going to plug in a plus h, and we get this f of a plus h. Well, since it's a constant, we get 4 again. So when I use the definition here, so let's take a look here. This is going to be, let's say here, this is my green portion. We know the value is 4. And let's use orange maybe. Here's the orange portion. It's also 4. And I haven't had my coffee yet. I'm going to let it cool, so there's a difference there. Okay, so what this means is this portion is 4, and this portion is 4. And as you can see, f prime at that value a is the limit as h goes to 0, 4 minus 4, everything over h. And this portion now is 0. So we get 0 over h, which is 0. And so if we take that limit now as h goes to 0, this is a constant, the derivative is 0. So what we have shown here is f prime of a is actually 0. And that's what we've shown. So it doesn't matter the value here of a. At every point, this constant function, the derivative is 0. And that's using just, again, algebra and the definition here. So there's one example. We're going to go to number 3. And we say the function here is 5x minus 2. We're going to find the derivative at that point. So remember here, we need to determine the value of the function at various points. This here is f of a plus h minus f of a, everything over h. Okay, so we're going to plug in now for this function a, and you get f of a, wherever there's an x, replace it with an a, right? So you're going to get now 5a minus 2. I'm going to plug in this a plus h now. We get f of a plus h, 5a plus h minus 2. So you're going to plug that in. Hot coffee. Okay. So all together, ladies and gentlemen, you might say, let's see, what colors did we use? I think this was green here. And we're going to use that green. And that goes right here, I guess. And the orange goes up in here. Okay, so let's see what we get. F prime of A is the limit. H goes to 0. 5a plus h minus 2 minus, I'm going to put a bracket, 5a minus 2. Everything over h. So we plug things in appropriately. You're going to use some algebra in this numerator, meaning you're going to distribute, because we have to simplify this. So we're going to distribute here. So we get the limit, h goes to 0, 5a plus 5h minus 2 minus 5a plus 2. And everything's over h. So you can notice here we can cancel the 2's, we cancel the 5a's. So using algebra, we get 5h over h. We can now cancel the h's. We get the limit of a constant. And the limit of a constant is a constant. Okay. So ladies and gentlemen, what we've seen here is this phi f prime of a is 5. And here's another example. Okay, those have been pretty good. Those have been pretty simple. So let's look at question 5 here on this sheet. And we have f of x is x squared plus x minus 5. And by the way, we're looking at formulas here. This is actually known as a formula for a derivative, right? F prime of a, because a is arbitrary. A can be any point, on the curve f. And, that derivative is always 5. So I just want to point out we're looking at really a formula. All right, so let's try this again here. We're going to have a warning of using the definition. It's like I said, I'll give you some more examples here using some algebra. So you start with the definition, a plus h minus f of a, everything over h. So again, we have to plug in values, right? We're going to plug in a wherever there's an x, so that we get f of a is a squared plus a minus 5. We're now going to plug in a plus h. A plus h becomes a plus h squared plus a plus h minus 5. Okay, well, what this means, again, if we say this green portion goes up here, this orange portion goes over here. And all together now you can start to see, we're going to need some space here, that f prime a is a limit, h goes to 0, a plus h squared plus a plus h minus 5 minus, put a bracket or a parentheses, it doesn't matter, and this will be over h. So I want to point this out to you. Here's the orange portion. guess, and here's the green portion. We're going to have to do some algebra, ladies and gentlemen. So let me get some coffee here. I'm going to start to do some algebra. All right. So, okay, so let's put that in red. Remember, we're saying here we're going to use algebra. So we're going to FOIL. And, really at this point, we're going to distribute. So FOIL on the left and distribute on the right. Okay? So that's where I'm headed. Let's change that color then so you guys can know we're using algebra. Should we use red? We'll use red for the algebra. FOIL a plus h. You guys should know that's a squared plus 2ah plus h squared plus a plus h minus 5. So I just did this first portion in orange. I'm going to distribute. Okay, so this is minus a squared minus a plus 5. Everything's over that h. Don't forget to put the h. So what's going to happen here is we're going to have some cancellation, right? A squared and minus a squared, they're gone. Positive a, negative a, that's gone. Negative 5, positive 5 is gone. And take a close look to see what's left, right? You have to always be careful to not leave a term out. All right. So remember, this is saying that f prime a is the limit as h goes to a, 2ah plus h squared plus h over h. Now, like I've been saying, we're going to be able to distribute here. You're going to be able to have that h go into every one of those terms. I mean, distribute with your division here. Divide every term by this h. And you end up with 2a plus h plus 1. So let's double check. Yeah, 2a plus h plus 1. And we're taking that limit. And this is actually a polynomial in two variables. You have the a variable, you have the h variable. So remember, h is 0. You plug that 0 in here. It's continuous. And you say this is 2a plus 0 plus 1. You're really saying that f prime a is 2a plus 1. So ladies and gentlemen, and remember this is a is a point on the curve, right? So I want you to note that you're looking at a formula for a derivative. It's a derivative formula. All right, so that's a formula for a derivative here. And, A is a point on the curve, right? So if we put some notes, we'll put a note over here. A is on F, meaning you have this point F of A for the y coordinate, A for the x coordinate. So this is the location of the point on the curve for the function f, and here's the derivative at that point. So, there's a relationship here, and I'm going to start to say, we're getting this in terms of a, but, I think I did mention this. What you can do here is replace that variable a with maybe x. And you say, I can do that? Yeah. And you say, why would I do that? Well, because you're used to seeing, for example, the point on the curve would be x, f of x, right? We're used to seeing, x to be our input, right? Variable, and y, which is f of x, is the output. And so if we're given a function in terms of the variable x, we often give the derivative in terms of the variable x. So, this is something that we transition to. We've been using a, and like I said, you say, why do I have the x notation? Well, they gave you the function in terms of x, right? This was number 5, which is x squared, plus x minus 5. So they give you the function in terms of this variable. So it kind of makes sense that you actually go back and say, okay, I get a as a fixed point. When we first learned this, we had to use that variable, but you transition to the x variable. Since it doesn't really matter, you can call that location on the curve a or x. Doesn't matter, but this is the logic behind it. So you are finding here really formulas for the derivative. These are known as derivative formulas, right? It's a variable. You give me a point on the curve, the value of x, like if x is 2, x is 8, x is negative 6, I can give you the derivative. And that's kind of where this variable x comes from and why. Anyway, let's look at some more morning examples here. Number 9. Did we do, no, we didn't do 7. We'll try 7. And we have f of x now becomes 2 minus 3x squared. We're going to find the derivative here as a formula. F prime a is the limit. H goes to 0. F of a plus h minus f of a over h, right? And, just to remark with what I just said, I said, you know what? They can replace this a with x. And let's go back to the black. So you can see this formula also in various books as the limit. H goes to 0. F of x plus h minus f of x, over h. So you can see this too, just so you know. All right, but let's go back to the a since we're used to it, and let's leave the x, out of this. How's that? So just a remark. So again, we need the green portion and the orange portion here, right? So you're going to plug in an a wherever there's an x, and you end up with f of a is 2 minus 3a squared. And then f of a plus h will be 2 minus 3 times a plus h squared. And we need more space. And here is the green portion. Here's the orange portion. So here it is. Here we go. Okay. F prime of a is a limit. H goes to 0 now. And let's plug everything in here, but I'm going to need space here. Okay, here we go. 2 minus 3 times a plus h squared minus 2 minus 3a squared, everything over h. So again, here is the orange portion. Here's your green portion. We're going to do some algebra. And you might say, what algebra we're going to do? Well, FOIL here and distribute here. And, you're going to see that h go away. So we have the limit. Let's do the algebra, actually. And we'll do the algebra in purple. So I might have to say, again, let's say use algebra like we've been saying in class, right? So we've been saying this, use algebra. So 2 minus 3, I'm gonna use FOIL here. A squared plus 2AH plus h squared. And then I'm going to distribute now. Minus 2 plus 3a squared. Everything over h. Now we're going to have to distribute again. 2 minus 3a squared minus 6ah minus 3h squared minus 2 plus 3a squared, everything over h. So when we see the cancellation, 2 minus 2 minus 3a squared, 3a squared, let's focus on what's left. You say, what's left? The minus 6ah minus 3h squared over that h. So, yeah, we'll continue with the purple. Right? And you say, you know, do I distribute the difference? Yes, h is dividing both terms. And that gives you minus 6a minus 3h. Okay, because one of these h's cancel. We have to take that limit. So f prime a is the limit as h goes to 0, minus 6a minus 3h. Again, a polynomial in two variables, right? You know, you can think of this a here as a constant. It's not, but you can think of it as it because the limit here has to do with the h variable. H is 0. So you plug in 0 here. Anyway, you get minus 6a minus 3 times 0, which really means f prime a is minus 6a. And there it is, ladies and gentlemen. Another formula. And in future sections, f prime x is minus 6x. All right, so that was number 7. So that means we're at 9. And my function for 9 here is x cubed plus 2x. Okay. F prime a is the limit. H goes to 0. F of a plus h minus f of a, everything over h. Remember here, we got the green, got the orange. I'm not sure if I'm using the same order of colors, but it doesn't really matter. Plug in the a wherever there's an x. You get f of a being a cubed plus 2a. If you plug that in, you can plug in a plus h now, plus h. And here's what you get. F of a plus h will become a plus h cubed. And since we're running out of space, we're going to move this over here. Plus 2a plus h. All right, so you guys have that here. All right, so double check here. You can plug this stuff in. Over here, the green portion is all of this, right? The orange portion is what you see up here. So you're going to plug that in. So f prime of a is the limit as h goes to 0. Let's do this. A plus h cubed plus 2a plus h minus the a cubed plus 2a, everything over h. So again, we're going to use algebra here. We're going to have to cube this. So this is going to be here. This is the third power. We're going to distribute here, right? And we distribute here. But I think the big key here, if I focus on this part here for the algebra for the beginning, is a plus h cubed. We're going to need to expand this. Okay, so we got a plus h cubed. Now, there's a formula here. I mean, this by definition is a plus h times a plus h, a plus h. And there's a formula here that we can actually use to expand this, and I might talk about that in our future, right? But, you know, for now here, I think I'm going to say, you know, use your FOIL here. And I'm going to show you the old-fashioned way, right? So you say this is a squared plus 2ah plus h squared. There's FOIL. And then you have this a plus h. And if you recall, how we do this is we take this a and we multiply with all the terms. And we take this h, we multiply with all the terms. But we're going to do this vertically, you know, so that we can add. So here's what I'm saying. A times a squared, we get a cubed plus, here's what I'm doing, okay, 2a squared h plus a h squared. And now I'm going to do the same with the h with all the terms here, okay? But I'm going to place them below the terms that I already wrote down. So a squared h there, that first one, a squared h, I put it here. Here's an a squared h. And then this is plus 2a h squared. And this is plus h cubed. So I put them below here. So now I can add vertically, right? Vertically meaning up and down here. So here's where the terms are like. And these, there's no like terms for the first and the last, but those two middle terms. And that's why you do this. So you get a cubed plus 3a squared h plus 3a h squared plus h cubed. And there's a formula called, there's an expansion formula for this that you learn actually in 260. Pre-calculus, you learn the expansion formula where if you have a power, a sum or a difference to a power, you can figure out, you can actually directly write this here. Anyway, that purple portion goes up here. All right, that's going to go, that's what we just found. And so you might say, okay, Mr. Judge, but you know what? I'm going to use what you did here, because there's not enough space to write everything down. And you're like, how are you going to write it all down and do the algebra? Well, I'm just going to do something here. How about if we do this? I'm going to distribute. You got 2a plus 2h, right? So plus 2a plus 2h by distributing. I don't see any of those terms anywhere. 2a plus 2h, excuse me. 2a plus 2h. So I'm going to write this down as plus 2a plus 2h. And then I'm going to distribute here again. I get minus a cubed minus 2a. So we get minus a cubed minus 2a. So I just did distribution of that negative sign here. And don't forget, we're going to have to divide all of this by h. So I might just put that here now so I don't forget. And what will happen now is I can actually combine the terms I need, right? Cancel, combine like terms, whatever. Notice, a cubed minus a cubed. 2a minus 2a. Is there anything else? Notice here, I can combine these two. I can add h, and 2h, I get 3h. So, let's go back and write down here what's left, right? Because you want to see that you get this term, these two terms are going to combine. They're all over h. So let's write that down. You have 3a squared h plus 3ah squared plus that 3h, everything over h. And yes, we distribute division, meaning 3 squared h over h plus 3a h squared over h plus 3h over h. And now you get to cancel. Cancel, cancel, cancel. So you are going to get 3a squared plus, looks like it's 3ah, there's an h there, plus that 3. All right, this is the algebra, ladies and gentlemen. And of course, you're taking that limit as h goes to 0, right? And again, it's a polynomial. It's, in two variables, which is, nice. We get to plug this in, direct substitution. It's continuous. Let h be 0, right? So here's where 0 is. And so notice what you get. We get f prime a will be 3a squared, really plus 3, because this portion will be 0. We like red for those kind of things. So that portion is 0. 3a squared plus 3. There you go. Here's your formula in terms of the variable a, or the value a. And again, we will transition to, in our future, to put f prime x, and that's 3x squared plus 3. All right, ladies and gentlemen, we got some more examples here. And, that one involves a cubic. And so cubics can take some time, right? Third power here. And now we're going to get to an interesting question. You guys may know how this works already. This is the square root of x minus 4. This is a square root function. Okay. So f prime a is the limit h goes to 0. fa plus h minus f of a, everything over h, our definition. Plug in the a again. F of a, square root, a minus 4. A plus h. F of a plus h, square root, a plus h minus 4. So you have the, and I might not be consistent with the colors, but I think you guys know this is, the term you put there first, the term you put second, by the way. All right, so you plug in those things in there into the definition. So we have f prime a here. Is the limit h goes to 0, square root a plus h minus 4 minus square root a minus 4, everything over h. All right, so now you might say, okay, if we apply the limit h is 0, you're going to get an indeterminate form, ladies and gentlemen. H is 0, right? So obviously, we can't have that. We have to use algebra. So as you guys may know, at this point, the kind of algebra they want you to use here, I'm going to write this down. We got a plus h minus 4 minus the square root a minus 4, everything over h. And you might say, what kind of algebra can I use? It's not subtracting rationals, right? It's not factoring. It's not using FOIL, But as you guys already know, we're going to multiply the top and the bottom by the conjugate. So we got a conjugate situation. Square root a plus h minus 4 plus square root a minus 4. A plus h minus 4 square root a minus 4. So this is the conjugate of the, the difference there, the irrational number, irrational term in the numerator. And as you guys know, when you FOIL here, because that's what's going on here, you're going to FOIL. You're really multiplying the F and L term because an O and I term goes away. So as we've seen in class, right, this really gives you a plus h minus 4. That's my first term in the FOIL. Whenever you multiply two radicals together, right, the radical goes away. And like I said, the O and I terms go away, so you don't have to do those. You just have to multiply the last terms, and that's minus now a minus 4, because you did the first radicals. Oops. Here's the first, and now here's the last. And don't forget there's a negative sign, so that's where the negative sign comes from. The radical goes away, and that's nice. And that's the key. The denominator, don't really multiply. Just keep it as h times a plus h minus 4 plus the square root of a minus 4. And you say, what happens now? Well, here's what happens. A plus h minus 4 minus a plus 4. H square root a plus h minus 4 plus the square root a minus 4. So when you're talking about this cancellation here, these terms are gone. A and a minus 4 plus 4 are gone, and your h's cancel because there's multiplication here, ladies and gentlemen. This is beautiful. So you have 1 over the square root a plus h minus 4 plus the square root of a minus 4. I like this question. Note to self, put this on the study guide or put this on the test. Yeah, so if any of you guys are watching this, you got a clue. That's called a clue. It's called a hint. Put this one on the test. Yeah, that's a nice one. Beautiful. Oh my God. See if you know a little bit of algebra. You should. You shouldn't be taking calculus without algebra. That's crazy. Who would do that, right? Anyway, apply the limit. H is 0. Here's h. Plug in the 0. All right. Let's apply the limit. Square root a plus 0 minus 4 plus square root a minus 4. And you say, what does this become? 1 over square root a minus 4 plus square root a minus 4. Combine like terms. Here you guys go. Here's f prime of a. It's 1 over 2 square root a minus 4. So here's your formula, ladies and gentlemen. And again, in future sections, you say f prime x is 1 over 2 square root of x minus 4. There we go. All right, let's see where we're at now. I guess that brings us to 13. 13. Okay, so 13, f of x is 5 over x. So f prime a is the limit, h goes to 0, f of a plus h minus f of a, everything over h. All right. Okay. So here's what I'm going to say. You guys know the drill. Plug in a to the function, and you have f of a is 5 over a. Plug in a plus h. F of a plus h is 5 over a plus h. All right, here you guys go. F prime a, you say, is the limit. H goes to 0 now. Maybe you want to color coordinate, blah, 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 blah. You know, I'm not sure. This goes here. Not sure if I'm consistent with my colors. So there you go. You guys know where this goes. So we have 5 over a plus h minus 5 over a, everything over h. Here we go. All right, so now you're in the situation where, you know, if you try to even plug in, you know, h is 0, you're going to get that 0 over 0 again, ladies and gentlemen. So you get 0 over 0. So we say we can't have that. We're going to have to use algebra. And the algebra we use, remember, we're going to subtract these rationals. So we're going to use that cross multiplication that we talked about, right? Remember this? Cross multiplication? Because we're really subtracting rationals, right? We talked about anything that looks like this, you know, a over b plus or minus c over d. That formula was AD plus or minus BC over BD, right? So maybe we'll put it over here and say this is equal, and put that over here. Okay, so let's do some algebra here. So cross multiply, that means 5a, okay, minus 5 a plus h, everything over a plus h times a. And that's, you know, the gray portion with the cross multiplication, our algorithm recipe for subtracting and adding, you know, unlike fractions. And don't forget, this has to be over h, because we have to include this division of h. Don't forget that. People often do. And then they kind of make mistakes. So don't forget that part. And, you know, so you guys know, remember what that really is. That's 5a minus 5a plus h over, I'm going to write it as a times a plus h. And don't forget, we're dividing by h, right? Which really means if you divide by a whole number, you're multiplying times the reciprocal. Just in case, you guys want to make sure you do this. So this is 5a minus 5a plus h. And this is now, I mean, you can say a, I guess we can do it this way. Who cares? Put the h there. And simplify your numerator, right? So you get now 5a minus 5a minus 5h, everything over a plus h times h. Notice the cancellation for the, you know, 5a and the, right in here, and your h's goes away. So here's what you're left with. Negative 5 over a plus h. Now that's the limit as h goes to 0. and this is f prime of a. So apply the limit for h. H is going to 0. Here's h, goes to 0. And so, ladies and gentlemen, you have negative 5 over a squared. And you say, why? Well, that's a times a plus 0, right? Isn't that a times a? Okay, there you go, ladies and gentlemen. And again, this will be in future. So we just write this in terms of x. Future sections. So here's your formula. And that was number 13, I guess, right? Okay, good. So let's do number 15 here. You say 15, the function is 5 over x squared. So we got f prime a is the limit as h goes to 0, f of a plus h minus f of a, everything over h. So you're going to plug in here a, like we've been doing. F of a gives you 5 over a squared. Plug in a, this is plus h, I get f of a plus h is 5 over a plus h squared. Okay. F prime a is the limit. H goes to 0. 5 over a plus h squared minus 5 over a squared. Everything over h. And I'll put this in a bracket here. All right. So we're plugging this in the definition again. And of course, if you plug in the value for h at this point, you'll get 0 over 0, and that's indeterminate. And I'll say you're going to subtract those rationals again. And you say, how do I do that? Cross multiplication, ladies and gentlemen. That might be a bit too dark over the blue. You can't see that. So cross multiplication. All right, there. We can see that better. So let's do the algebra. And I'll write this down. Use algebra. And we have 5a squared, right, minus 5 times a plus h squared, everything over a plus h squared times a squared. Now, again, divide by h. So, divide by h. And to say to you what happens here with this algebra, I want you guys to see this. At this point, you should know that, yeah, we're going to divide by h, which is multiplying by the reciprocal. But what you should know, right, multiply by the reciprocal, that's division by h. But what you should know is that this h is going to go down here now, right? That's really what's going on. And don't forget here to continue your algebra, but you can't distribute yet. You're going to have to, oh, I know, my eraser's too big. Now, okay. You have to use foil here. So the algebra continues. This is a squared plus 2ah plus a squared, and you're going to distribute that negative 5. You're going to multiply negative 5 to all those terms. So let's see what we end up with, right? From some algebra, we have 5a squared minus 5a squared minus 10ah minus 5h squared, everything over a plus h squared, h. Okay, let me put mute so I can cough. All right, let's actually simplify, right? So, these terms cancel, right? And notice what you're left with, ladies and gentlemen. What are we left with? Yeah, let's write this down here so you guys can see this. Negative 10ah minus 5h squared over a plus h squared, a squared h. And at this point, let's really take a close look, because people are going to look at this and they're going to go, hey, Mr. Judge, I thought my h's cancel. How are they going to be able to cancel here? Right? So I'm going to say something here. Look at this here. You got an h, you got an h squared. So we can do it this way. I'm going to say factor out an h minus 10a minus 5h. We factor the h out. A plus h squared, a squared over h. And then what happens here with this h? H is gone. Minus 10a minus 5h over a plus h squared, a squared. So sure enough, the h will go away. And the trick there was to factor out the h term, right? Greatest common factor, I guess. And you could have factored that further, but the point is to get the h's to cancel, because they will cancel. If you've done the algebra correct, the h goes away, ladies and gentlemen. And now remember, we take the limit. So we have f prime a is the limit. H goes 0. So wherever there's an h, here and here, you get to put a 0, right? So here's what we end up with. Negative 10a minus 5 times 0, a plus 0 squared, a squared. So notice this. We get 0 here, and this portion is just going to be a. So here's my final answer, right? F prime a is minus 10a over, looks like it's going to be a squared. Yeah, remember this is a, so take a look down here. That's a squared times a squared, which is a to the 4th, okay? Because we're focusing here. A plus 0 is a, but don't forget it's being squared. And then it's multiplied to a squared. So you get a to the 4th down there. Now, you can simplify here, ladies and gentlemen, that a does cancel with one of the a's down there. So we have f prime a becomes negative 10 over a cubed. There you go. So in a future course, we call that f prime x. That'll be negative 10 x cubed. Alrighty. Pretty nice. Pretty nice. Okay, now, I guess that leaves us with question number 17. Kicking these up. What does 17 look like? Oh, it's 1 over the square root 2x plus 1. Okay, let's find out what this is. So now we're going to plug in an a here. F of a is 1 over square root 2a plus 1. Add h, add h. F of a plus h is 1 over square root 2a plus h plus 1. Double check here, ladies and gentlemen. Right? So you're plugging in here now for x, the a plus h. So you're going to end up distributing down there. But, you know, we could leave it as it is for now. All right. So let's go with this. We have, I guess, I don't know. We'll call that green. I don't know what. This one is green. It goes here. You guys already know that. Here's my orange. It goes in here. You know that already too. So f prime a is that limit. H goes to 0. Let's plug everything in, right? 1 over square root 2 a plus h plus 1 minus 1 over square root 2a plus 1. This is everything over h. What do you do with that difference? Right? If you plugged in h at this point, you get 0 over 0. So we're going to have to do some cross multiplication here, right? And let's get the right color. Oh, geez. Here we go. Okay, here we go. We're going to do the algebra. So I'm going to say use algebra. And let's see what we get. We're doing an algebra in purple. So we get square root 2a plus 1 minus square root 2a plus h plus 1. Everything over square root 2a plus h plus 1 times 2a plus 1. And then don't forget, divide by h. And you might say, what does that really do for me? Well, here's what you end up with, right? We're still doing algebra, so let's keep it purple. What do we end up with? Here's what we get. Square root 2a plus 1 minus square root 2a plus h plus 1 over 2a plus h plus 1, the square root 2a plus 1. Don't forget you're dividing by h, which really means the h is down here outside of the radical, right? So you can start putting that now. And if you plug in, if you try to do the limit, by the way, you're going to get the indeterminate form. So I'm going to say to you, remember, we're going to try to take this limit as h goes to 0. You get an indeterminate form of 0 over 0. Okay, so you say, what algebra do I use here? Use algebra, use the conjugate. So, okay, we are actually going to need to start to write smaller. Okay, so we have this already. This is what we have. Square root a plus h plus 1, square root 2a plus and that's not h, that's 1. And I have an h here, but I have to multiply by the conjugate of that numerator. All right. All right, so you say, what's the conjugate? Well, I'm going to have to do smaller. It's plus 2a plus h plus 1. 2a plus 1 plus square root 2a plus h plus 1. It's smaller here. Here's the conjugate, remember? This is negative, positive. And parentheses. So FOIL, first, outer, inner, last. It's really F and L. So here's what you get. You just get 2a plus 1 without the radical minus, put a parentheses. And in fact, it's not just a parentheses, put a bracket. 2a plus h plus 1, because we already have a parentheses. And then don't, ladies and gentlemen, don't multiply the terms here. This is going to be 2a plus h plus 1 square root 2a plus 1 times that h times square root 2a plus 1 square root 2a plus h plus 1. Okay, so up here you use algebra. So your algebra now is going to be in the numerator here. We get 2a plus 1 minus, I guess we'll do this, 2a plus 2h plus 1, right? And that's in my numerator, so I'm focusing on this numerator. There's a lot of work here. There's the numerator. Let's just focus on that algebra. 2a plus 1 minus the 2a minus the 2h minus the 1. That's my numerator again. And let's double check. Okay, yeah, that's the numerator. And then we're going to see what cancels at this numerator, right? 2a minus 2a, 1 minus 1. We just have that minus 2h left. All right, that's the numerator. So we have minus 2h. We're now going to write down this whole big denominator. I'm going to change the color. And you get square root 2a plus h plus 1 square root 2a plus 1 times that h times square root 2a plus 1 square root 2a plus h plus 1. And then, ladies and gentlemen, the h's cancel. Sure enough, if you did the algebra correct, your h's will go away. So this is negative 2, right, over square root 2a plus h plus 1 square root of 2a plus 1 square root of 2a plus 1 square root of 2a plus h plus 1 here. And let me move this over because, as you guys know, we need to take that limit as h goes to 0. Okay. At this point, wherever there's an h, put your 0. Direct substitution, or the fact that it's continuous. So f prime a will be, negative 2 over, this is going to be 2a plus 1. This is the first one. This is going to be 2a plus 1, the second one. 2a plus 1, the third one. 2a plus 1, the last one. So you might say, how many of these do I have? Well, ladies and gentlemen, looks like you have, this is to the 4th power, so you have the square root 2a plus 1 to the 4th power. And I want you guys to notice something here. We're still using algebra. 2a plus 1 to the 1/2 raised to the 4th power. Focus on the power. Properties of exponents. What does that give you? 1/2 times 4 squared. F prime of a is negative 2 over 2a plus 1 squared. So there it is, ladies and gentlemen. There is that long problem here. Interesting, and again, in future sections, they just changed the variable to x. Yeah, my f's are losing their snap. Negative 2, 2x plus 1 squared. Anyway, here's a morning example of some of these, derivatives by using the definition. And I promise you guys I get some examples up using some algebra for you, and here it is. I hope you guys appreciate it. I'm going to upload it, and I'm going to let you guys know it's there. So have a great, Saturday. I'm going to stop right here. I got a few things I got to do, and have a great day. Okay, here you go.